Hassler here. I'm going to work through the 10.2 Explore. These are the problems that we worked on at the board with our groups. And then I'm going to do the quick notes for 10.2. Your job will be to work on the check your understanding. All right, so yesterday we were talking about point slope form, and we were pulling information out of that point slope form. So just a reminder, point slope form looks like this. Y equals the slope times x minus the x coordinate of an ordered pair, and then parentheses, plus the y coordinate of the ordered pair. And so some things that we can pick out the slope, and then we can pick out the x coordinate and y coordinate of a point that's on the line. Well, we could also go in reverse. So I could give you that information, and using that information, we can create a point slope equation. And so that is what we are going to do. Okay. So in this case, I have a slope of 3 and the point 9, 2. Remember, that 9 is the x coordinate and 2 is the y coordinate. So in my equation, I would say y equals the slope, negative 3, parentheses, x minus that x coordinate, 9, minus 9. Wrote 9 there before writing minus. There we go. And then plus 2. Now let's just pause and make sure that what we wrote seems reasonable. If this is a positive 9, that means that I shifted right 9. And if this is a positive 2, that means I shifted up 2. And so I just want to make sure that my equation reflects that. Minus 9 in the parentheses means I shifted right 9. And plus 2 on the outside of the parentheses means I shifted up 2. So it seems reasonable that I would have this equation, and it would match this point. All right, so let's do the next one. I've got y equals my slope, which is 4/3, in parentheses, x minus. Okay, well, this is negative 5. So for now, I'm going to write x minus negative 5. And then I have this plus 13. But this minus and negative 5 seems like more than I need to write. I could simplify this or rewrite this. Minus and negative is the same as saying plus. So I really have y equals 4/3, parentheses, x plus 5. And then parentheses, and then plus 3. And again, let's just do a check, right? So minus 5 means that I must have shifted left by 5. And if I shift left 5, that should show up as a plus 5 in my equation. And it does. Plus 13 means I shifted up 13, and that should show up as a plus 13. Oops, I wrote plus 3. Plus 13, good thing I checked, right? Plus 13 in my equation shows that I shift up 3. And so we can write a point slope equation. Whatever the shift is based on the point, if it's an x, I'm going to use the opposite sign in that equation. And if it's a y, I'm going to write exactly what I see. So instead of writing minus negative 5, I could just write this as a plus 5, which indicates I shifted left 5. All right, let's try another example. So same story. We're going to write the equation in point slope form. So I've got y equals 1, parentheses, x. All right, this is minus 8. That's really a shift left 8. So I could write that as x plus 8 in my equation. Right? It'd be like saying minus negative 8 or plus 8. And then this is a shift down 6, so I've got minus 6. And so this would be my equation. And over here I have a slope of half. So y equals 1/2 x minus 11, right? This is positive, so shift right 11, which means I need a minus 11 in my equation, and then minus 4. Okay, now I can always graph these in Desmos, and if I graph these in Desmos, I should have the slope of that line, and that point should show up on my line, and so we can always use Desmos to check. All right, so next type of problem is given the graph of a linear function, write the equation of this line. And it doesn't tell me how to write the equation of this line. So again, we have this point slope that we're working with, y equals m, in parentheses, x minus x1, and then plus y1. Or we could do y equals mx plus b. Okay, so it doesn't say what point to use either. So let's see, I have so many points here that I could use. And so I'm going to write a couple equations. So this point right here would be -5, -2. And so my equation, and I would have a slope of, let's see, rise over run. So down 1 to the right 1. So a slope of -1. Okay. So one equation I could have is y equals -1 parentheses x. Well, -5, sorry, I circled that in white, but you can't see it. -5 means I went to the left 5, so it's really a +5 in my equation, and then down 2, so -2. Let's pick a different point. I could have used this point -2, -5. Oh, that's interesting, right? Because now I got to flip this around. So I have y equals -1, x this time +2, right? I shifted left 2 and then down 5, so that's interesting. Or I notice that I have the y-intercept right here at -7. So I could write a slope-intercept equation. Y equals -1x minus 7. And these equations all end up representing the same line. If I graphed all three of these in Desmos, I would get the same picture that I have on my screen. And so there are now, because of point slope form, infinitely many ways to write the equation of a line. All right, let's do this next one. So this next one says, given the graph of the linear function, write the equation of a line. And again, it doesn't tell us what type of equation to write, point slope, slope intercept. So let me just pick out some points here first. Lots of points. Okay, and so let's pick out this point here. We've got 6, 2. Let's see, my slope looks like it's a slope of 2. And so I could have y equals 2, and then parentheses x. 6, 2 means I went right 6, so x minus 6, and then up 2, so plus 2. Let's do another one. Let's say that I had this point here for -2, and so I'd have y equals 2, and then x minus 4, and then minus 2. The thing is, though, I can't see the y-intercept, like it's, down here off the screen somewhere. So let's put an equation, though, into y equals mx plus b form, but I can't really see what that y-intercept is. Well, what I could do is I could simplify this. So when I say simplify, I mean let's go ahead and distribute. So let's distribute that 2. That gives me 2x minus 8 minus 2. And then I can combine like terms. I get 2x minus 10. Yeah, it seems reasonable that I could have a y-intercept at -10. And so, again, even though I couldn't look at the graph to write slope-intercept, I was able to simplify my equation in order to write a slope-intercept. All right, let's do another one. Same thing, it says, given the graph of the linear function, write the equation of a line. And it doesn't tell you what type of equation to write, but what I do notice here is that I can see my y-intercept, but boy, is that a quarter? Is that a third? I'm not really sure. So I can't, if I'm not certain what the y-intercept is, I can't guess what it's going to be. Okay, but I can pick out some points. So let's see. Here's a point. Here's a point. Here's a point. Okay, so I have several points here. So let's take a look at this point right here. That's what, -5, 3. It looks like I have a slope of down 1, 1, 2, 3. So a slope of -1/3. All right, so let's write an equation. Y equals -1/3 parentheses x. Okay, -5, that means I went minus -5 or plus 5. And then plus 3. So that's one equation we could write. Let's do an equation with this x-intercept, right? I got 4, 0. So I could write the equation y equals -1/3, and then x, I went right 4, so minus 4 plus 0. Okay, I guess I don't really even need the 0. I could just have left it as, this with no plus 0. Okay. And hey, let's go ahead and put this into slope-intercept form, right? Like, let's simplify into slope-intercept form. And so, again, that means that we're just going to distribute. And when I distribute, I get y equals negative 1/3 x plus negative times negative is a positive 4/3. And because that plus 0, I don't have anything to combine it with. If I rewrite this, I really have negative 1/3 x plus 1.3 repeating. And yeah, that seems reasonable. 1 1/3 seems reasonable for my y-intercept. And so I can write multiple point-slope equations. I can simplify those to be a slope-intercept. There's only one slope-intercept equation because I only have one y-intercept. But there are infinitely many point-slope equations because there are infinitely many points on the line. All right, last one. It says the table below shows the linear relationship between x and y. Write an equation for this relationship. So again, it's not specifying what equation type. I don't see the y-intercept. No y-intercept. Although I do see an x-intercept, but that's not really helpful in terms of writing a y equals mx plus b. They also didn't tell me the slope, so I'm going to have to come up with that slope. So just a reminder, slope is change in y over change in x. And so my change in y looks like I'm going down by 2, negative 2. And my change in x, it looks like I'm adding 4. And if I simplify that, I get negative half. Okay, now to write a point-slope equation from a table, it actually does not matter which equation you use. So I'm going to write 3 different equations for you. I've got y equals negative half times x minus 7 and then plus 4. That's for the red one. This middle one, I would write y equals negative 1/2 x minus 11 and then plus 2. Or that blue one, I could write y equals negative 1/2 x minus 15 and then plus 0, where I don't even have to write the plus 0. And then if I wanted to put this into slope-intercept form, I'd actually prefer to distribute this last one since I have that plus 0. So I get y equals negative 1/2 x. Negative times negative is positive, and half of 15 is 7.5. And so I have 3 different point slope and 1 slope-intercept. All right, so let's jump over to our quick notes. And in our quick notes, I just want to remind you that we have this point-slope equation. The point-slope form of a line is that y equals m parentheses x minus x1 and then plus y1. Just a reminder, m is the slope. And then your point, this is why it's called point slope form, right? I can pick a point and a slope. Your point is x1, y1. And just a reminder there that we use the opposite sign when it comes to those x's. I also wanted to make sure that we reviewed slope-intercept form. Slope-intercept form is that y equals mx plus b. M, of course, is the slope, but b, remember, is that y-intercept. And then I want to do a quick example in here. So for example, if I have y equals 1/2 x minus 6 plus 5, and I want to get this into slope-intercept form, I can distribute the half. So I have y equals 1/2 x minus 3 plus 5. And then I can combine my like terms. So I have y equals 1/2 x plus 2. So I can start with the point slope equation and simplify my equation so that I can get a slope-intercept equation. So I can start with point slope and end in slope-intercept. All right, so your job is to work through the check your understanding. Please make sure that you read through all of the directions, and if you have questions, let me know.